Alright YouTube, today we're taking a look at a simple series circuit. And in this problem today we're going to solve for the equivalent resistance, as well as the total current coming out of the battery. And we're also going to solve for the total current and voltage through each of these resistors. Now looking first at the equivalent resistance. Ultimately, the question we're trying to answer when solving for equivalent resistance is what single resistor could I put in this circuit or replace these other resistors with that would produce the same current and therefore power draw out of this battery. Now resistors can be combined in two different ways. The first is series, as we see here. And the easiest way to identify two resistors which are in series is to look to see whether or not there's any intersections or breaks in the wire between the two resistors. See, if a charge passes through one resistor and then it must continue on through the other resistor, it means those two resistors are in series. Now mathematically, we can combine resistors in series simply by adding them together. And by adding these two resistance values together, we'll get the equivalent resistance of these two resistors. See, these two resistors combine to be equal to a single 18 ohm resistor. And so ultimately we've taken this circuit and reduced it down to a single power source, a battery, and a single resistor. And now that we have the equivalent resistance, we can solve for these other values which we're concerned with. So starting here with our simplest version of this circuit, we can now solve for the current coming out of the battery. See, if we apply Ohm's law to just this simplified circuit, we see there's a 9 volt power source and 18 ohms of resistance, and we're simply solving for the current coming out of that power source. So using Ohm's law, we've got 9 volts are equal to the current coming out of the battery multiplied by the total resistance of this circuit. That's 18 ohms. And we find the current coming out of the battery is 1/2 or 0.5 amps, where amps are the units of current. So now, having simplified this circuit down to a simpler form, and having found the equivalent resistance and current coming out of the battery, we can go back to our more complicated circuit in order to solve for the current and voltage across each of these individual resistors. Now, knowing the current out of the battery is 0.5 amps, we can apply that same current to this circuit over here. See, these two resistors behave as though they're an 18 ohm resistor, which in turn draws 0.5 amps out of this 9 volt battery. Well, this circuit is no different. We have an effective 18 ohms of resistance, which are going to draw 0.5 amps of current from this 9 volt battery. And if you look closely at this circuit, you'll notice if there's 0.5 amps of current coming out of the battery, that same 0.5 amps of current must travel through this resistor. There's nowhere else for it to go. There are no other wires. So there's going to be 0.5 amps of current passing through the 6 ohm resistor. And as it continues downward, there's going to be 0.5 amps of current traveling through this 12 ohm resistor as well. And again, we're going to apply Ohm's law, this time to these two resistors, in order to solve for the voltage drop across each individual resistor. So looking first at this 6 ohm resistor, we know there's 6 ohms with 0.5 amps of current. So multiplying the current by the resistance, we can solve for the voltage across this 6 ohm resistor. That's going to work out to be 3 volts. Next, looking at our 12 ohm resistor. There's 0.5 amps of current passing through a 12 ohm resistor. That's going to leave us with 6 volts of potential used up across this resistor. Now the last thing I want to do might seem a little tedious, but it's a real good way to check to make sure we've analyzed everything in the circuit correctly and we have no mistakes. So you're looking at this battery. We know on one side of the battery the charge has 9 volts of potential. And in going through this entire loop, there should be a change in potential such that when the charge gets back to the battery, there's 0 potential left. Or to put it differently, if the charge starts with 9 volts of potential, it has to use up 9 volts of potential in going through this loop. Well, you'll notice, As the charge moves through this 6 ohm resistor, it used up 3 volts of potential. And then in passing through this 12 ohm resistor, another 6 volts were lost. Well, if we start with 9 minus 3 minus 6, that charge is going to finish up with 0 potential, exactly as we would expect. So this is how you solve for the equivalent resistance, current out of the battery, as well as the current and voltage across each resistor in a series circuit. I hope you found this useful, and on that note, that's all for now.